I did not see you then. Have you ever wanted to differentiate advanced equations? Well, now you can with derivatives and integrals. I'd like to introduce my colleague. He'll be teaching about derivatives and integrals.
Alright, so basically a derivative is a measure of how a function changes as its input changes, as shown here by dy over dx, whereas an integral is the area of the region in the xy plane bounded by f, the x-axis, and the vertical lines x equals a and x equals b. Also refers to the antiderivative, as shown right here.
Hello children, today we're going to talk about derivatives of course, and we're going to talk about two different methods of using them. First, we have the product rule. Now this is normally used when you have two variables multiplied together, and the formula that we use is f prime times g plus f times g prime. And we do this because we have our f function and our g function when they're multiplied together. So here, our Professor Sanjay gave us two problems here. So we got a problem here, we got a problem here. So we got 3x squared times 2x. Working this problem out, we have f prime, which is 6x, because we do our chain rule, which will be explained later if you don't know that, kids, times 2x, which is this function right here. Then we add, right here, see this, 2, which is the derivative of 2x, times our normal function, 3x squared. Okay, so we work out the math here, we do a little bit of multiplication. I know that's pre-algebra stuff, we got that. We got 12x squared plus 6x squared, and conveniently they add into each other, so we get 18x squared. Now that we have product rule all done, we'll do the quotient rule. And the quotient rule, just like in the product rule, we have two functions, but in this case, you divide across. Now division is a little bit different than multiplication, we all know that. So we have, for this one, our method is g normal function times f prime x. So that's the top function's derivative multiplied by the normal original function. And here you subtract, so you have our normal f of x, which in this case is 3x squared, times our derivative of our lower, which is 2 in this case. So here we have our problem. We have 3x squared divided by 2x, so we use our formula, and we get 2x from the g, because it's normal, times f prime x. And that gives us 6x. Now we subtract, unlike the product rule, and we are given 3x squared from our normal f of x function times our derivative of 2x, which gives us 2. And we all divide that over by gx squared right here. Look at that beaut. So, we multiply this out, we're going to get 12x squared minus 6x squared, which conveniently comes out, that's nice, divided by 2x squared, because that's our function squared. Great. So, we subtract here, and we get 6x squared, all divided by 2x squared. Isn't that nice, gents? We get 3 as our answer, and that is math. But wait, there's more! Now the chain rule is another method of solving a derivative. In this case, it is normally used when there is a specific exponent or power to a specific function. As seen here, we have x squared plus 3 to the 7th. With this extra power here, we get to chain it out and eventually get to our answer. So let's go step by step. First we start with our function, x squared plus 3 to the 7th. We start out by taking this exponent and bringing it to the front of the equation. That is how we are chaining out or moving this exponent to the front so it can be used later. In doing so, we subtract 1 from this exponent because we're taking it out here and it gives us 6. Kind of hard to read, I know, sorry about that. 6, alright, 6, there we go. Now that we have this done, we're not done that. No, we're not done. No. We have to find the derivative of this inside right here. So, knowing what we know about derivatives, because we're so smart, we know that x squared is equal to 2x in derivative, and 3 goes away because that becomes 0 because there's no exponent. So what we're given is 7 parentheses x squared plus 3 to the 6th, because we have to keep this function right here, and then we find the derivative, and 2x right here. So that's our function right here. So let's multiply it out, and we are given 14x parentheses x squared plus 3 to the 6th. And that, my friends, is the chain rule.
Hi, My name is Taylor, and I'm here to teach you about integrals. So integrals are basically the opposite of derivatives, and it can be described by the equation f of x dx, where b is the bigger number and a is the smaller number, which explains the range of an area underneath, for example, a curve, as displayed here. Now, a mock question is, let's take the integral of 3x squared plus 2, and then we write the dx at the end. So you want to add 1 to the exponent, so add 1 to the x squared, so that becomes x cubed, and then multiply the coefficient by, which is 3, by 1/3, giving us x cubed plus 2x plus c. And then the a and b comes into play where a is the limit from here to here, and basically the area underneath the curve from there to there is our range. And that's integrals.
So, you are probably wondering, when the heck will I use derivatives and integrals in real life? Let me tell you. Derivatives and integrals have many applications in modern day physics as well as other subjects. For example, derivatives apply to distance, time, and acceleration. The derivative of distance will give you time. The derivative of time will give you acceleration. Thank you for watching.